Earth is the only home humanity has ever known. Every breath you've ever taken, every civilization ever built, and every story in human history has unfolded on this single planet. But Earth won't last forever. In around 1 billion years, our sun will become bright enough to make our planet increasingly hostile to complex life. Long before that, asteroid impacts, supervolcanoes, or even our own actions could threaten civilization. If humanity wants to survive for millions or even billions of years, we'll eventually have to look beyond Earth. But can we? Could humanity really live on another world, or are we forever bound to the only planet we've ever called home? Although Earth is remarkably stable on human timescales, astronomy tells a different story. Our sun is slowly becoming brighter as it fuses hydrogen into helium within its core. Over hundreds of millions of years, this increasing luminosity will gradually warm Earth's climate. Current models suggest that in roughly 1 billion years, conditions may become too hot to sustain Earth's oceans, making complex life increasingly difficult. Eventually, around 5 billion years from now, the sun will exhaust the hydrogen in its core and expand into a red giant. Its outer atmosphere will stretch deep into the inner solar system. Whether Earth is engulfed completely or survives in a scorched orbit remains an active area of research. Either way, our planet will become uninhabitable. Fortunately, humanity doesn't need to solve that problem tomorrow. But if our species hopes to survive over cosmic timescales, remaining on Earth forever simply isn't an option. Whenever people discuss humanity's future beyond Earth, one planet dominates the conversation: Mars. At first glance, it seems like the obvious choice. A day on Mars is only around 40 minutes longer than one on Earth. Water ice exists beneath the surface and at the poles. The planet experiences seasons and weather, but Mars is far from a second Earth. Its atmosphere is less than 1% as dense as ours and is composed mostly of carbon dioxide. The average surface temperature is around -63 degrees Celsius. Without a pressurized habitat, a human would quickly lose consciousness. The planet also lacks a global magnetic field, leaving its surface exposed to higher levels of harmful cosmic and solar radiation. Even so, Mars remains the most practical location for humanity's first permanent settlement beyond Earth. Not because it's easy, but because everywhere else is even harder. One of the greatest challenges of living beyond Earth isn't the cold, or the lack of oxygen, it's something you can't even see: radiation. Earth is protected by both its thick atmosphere and magnetic field, which deflect many charged particles from the sun and deep space. Away from those natural shields, astronauts received significantly higher radiation doses. Over long periods, that exposure increases the risk of cancer, damage to the nervous system, cataracts, and potentially other health effects that scientists are still studying. On a journey to Mars, astronauts would spend months traveling through deep space before even reaching the planet. Protecting future crews may require habitats buried beneath soil, thick water shielding, specially designed spacecraft, or combinations of several approaches. Radiation isn't necessarily an impossible problem, but it is one that every long-term space mission must overcome. If humanity hopes to become a multi-planet species, surviving isn't enough. Future generations will need to be born away from Earth. The truth is, we don't yet know whether that's possible. No human has ever conceived, carried, or given birth in space. Scientists know that microgravity affects muscles, bones, circulation, and many other biological systems. Experiments involving animals suggest that altered gravity can affect reproduction and early development, although results vary depending on the species. Exactly how reduced gravity would affect human pregnancy remains unknown. Until extensive research is conducted, any discussion about families living on the Moon, Mars, or space stations remains speculative. It's one of the biggest unanswered questions in human spaceflight. Science fiction often imagines transforming entire planets into new Earths. This idea is known as terraforming. The most commonly discussed candidate is Mars. In theory, increasing atmospheric pressure and temperature could allow liquid water to exist more easily on the surface. However, today's scientific evidence suggests this would be extraordinarily difficult. Current studies indicate Mars probably doesn't contain enough accessible carbon dioxide to create a thick Earth-like atmosphere using existing technology. Even if it did, maintaining that atmosphere would be challenging because Mars lacks a strong global magnetic field. Terraforming isn't impossible according to the laws of physics, but with current knowledge and foreseeable technology, it remains a hypothetical concept rather than a realistic engineering project. For the foreseeable future, enclosed habitats are far more practical than changing an entire planet. Perhaps we don't need another planet at all. Instead of adapting worlds to suit us, we could build our own. Scientists have proposed enormous rotating space habitats for decades. By spinning, these structures could create artificial gravity through centrifugal acceleration. People living on the inside surface would feel pulled toward the outer wall, much like gravity on Earth. Concepts such as the O'Neill cylinder suggest entire communities complete with farms, homes and parks could exist inside these vast structures. None have been built. The engineering challenges would be immense. But unlike faster-than-light travel or fictional gravity generators, rotating habitats rely on well-understood physics. The biggest obstacle isn't whether they could work, it's whether humanity could build something on such an enormous scale. When people imagine colonizing the solar system, planets usually receive all the attention, but some moons may actually be more interesting. Europa, a moon of Jupiter, almost certainly hides a global ocean beneath its icy crust. Enceladus, orbiting Saturn, ejects enormous plumes of water vapor and ice into space. Titan possesses rivers, lakes and seas, not of water but of liquid methane and ethane. Despite these fascinating environments, none are likely to be comfortable places for humans. Surface temperatures are extremely low, sunlight is weak, and in Jupiter's case, intense radiation makes Europa's surface particularly hazardous. These worlds may prove invaluable for scientific exploration and the search for microbial life. As places for permanent human settlements, they remain far less practical than Mars. Even if humanity successfully colonized our solar system, another challenge would remain: the stars. The nearest star system beyond our own is Alpha Centauri, located approximately 4.37 light-years away. That may sound close, in reality it's unimaginably distant. Using today's rockets, the journey would take tens of thousands of years. Scientists have proposed ideas such as nuclear propulsion, fusion engines, laser-driven light sails, and generation ships. Some of these concepts are grounded in known physics, others remain highly theoretical. None are close to carrying humans between stars. For now, interstellar travel remains one of humanity's greatest engineering challenges rather than an achievable reality. Perhaps the biggest obstacle isn't the planets, perhaps it's us. Human beings evolved specifically for Earth's gravity, atmosphere and environment. Instead of changing other worlds, future generations may one day consider changing themselves. Advances in genetics, medicine, prosthetics and biotechnology could theoretically help humans tolerate harsher environments. However, any discussion of genetically adapting humans for space is highly speculative. It raises enormous scientific, ethical and legal questions. At present, there is no proven method for safely engineering humans to thrive on another planet. For now, protecting people with technology remains far more realistic than redesigning human biology. After everything we've explored, one question remains: can humanity really survive beyond Earth? The answer depends on what we mean by survive. Short-term missions? We've already achieved them. Permanent research bases on the Moon or Mars? Many scientists believe they are technically achievable within the coming decades, although major engineering, financial and political challenges remain. Self-sustaining colonies that no longer depend on Earth? That is a far greater challenge, and one we have not yet solved. Interstellar civilization spanning the galaxy? That remains firmly within the realm of speculation. But history shows that humanity has repeatedly accomplished goals that once seemed impossible. The challenge isn't whether the laws of physics allow us to leave Earth, it's whether we have the knowledge, resources and determination to do it. For more than 300,000 years, humanity has lived on a single world. Everything we are has been shaped by Earth's gravity, air, water and sunlight. Yet the universe doesn't promise that our home will last forever. If our species is to survive for millions or perhaps billions of years, expanding beyond Earth may eventually become more than an ambition. It may become a necessity. The path won't be easy. Radiation, low gravity, hostile environments and unimaginable distances stand in our way. Many of the ideas we've discussed remain theoretical. Others are already being tested today. Whether humanity builds cities on Mars, giant rotating space stations, or finds an entirely different solution, one thing is certain. Our future will depend not only on our technology, but on our curiosity, because every great journey begins with a single step. And for humanity, that first step has already been taken. Thank you for watching this video. I hope you enjoyed the end of Phase 2 and exploring whether humanity could survive beyond Earth. Let me know if you have any theories on potential ways we could survive beyond Earth down in the comments. Make sure you hit the subscribe button, and if you have anything you would like to explore with me in a future video, I will do my best to make that happen. Stay tuned for the next video where we begin Phase 3 and talk about the fastest things in the universe, and as always, stay curious.